Ladies and gentlemen, please welcome our next speakers, Martin Sakowski and Marina Burkhardt, presenting the topic, the future of platform engineering.
Good afternoon, everyone. Glad to see so many people in our session today. Hope you enjoyed your lunch, had great lunch, and you get back with full energy for another session. Let me kick off that session with a question. Who of you is using a platform? That's nearly everyone. Another question. Who of you is building a platform? Great to see so many builders of platforms. So it seems that platforms are a thing nowadays. Platforms are a very popular concept, and we want to talk about why platforms are so special and also how we can build great platforms. My name is Martin Sakowski. I'm a senior solutions architect with Amazon Web Services, and I have a long history in building digital platforms, architecting them, designing them, and actually building them. And as a solutions architect, I'm interested in how to build the platform that is future-proof. And I'm not here alone today. Marina.
My name is Marina Burkhardt. I'm also a solutions architect at Amazon Web Services, and actually I'm a former DevOps engineer. So that means that I truly understand which one are the pain points that developers have, but also the operations team have. And with that DevOps mindset and the practices and the perspective, I'm going to also introduce you to the platform engineering, how this is key for a successful organization.
So you see two different perspectives on the topic, and we want to share our perspectives on that topic today, how to do platform engineering. But before we look into the future of platform engineering, let's take a look back. Why are we building platforms? And what are platforms? Well, the word platform is a bit overused recently, I would say. What do we mean if we're talking about a platform? In IT, I would say it's a group of technologies that you can use as a base for something. And upon this base, you can develop some applications, you can develop processes or other technologies on top of that. So we have common components that do some generic stuff. And then on top of that, we build something that is not generic, that is the opposite, that is special, unique, that has a distinct purpose. So, and this concept of doing that is not new. So we find it in many industries, and platforms have actually transformed entire industries. I brought an example that most of you are familiar with, the automotive industry. It's a very complex industry, to be honest. Lots of engineering, you have difficult manufacturing processes, high safety, regulatory requirements, and also like a fast development cycle. The question here is like, do they design every single piece for every new model from scratch? No, they don't do that. They use platforms like the chassis, the wheelbase, transmission, engines, brakes, and so on. These are the most complex parts of a car. But the customers don't really see that. The customers often don't really value that, but you need all of this. The customers, they look at the color, they look at the interior, the size, some tangible features that are interesting for them, and then they buy a new car. So the automotive industry has realized that they have to do this heavy lifting under the cover only once. They build a platform. And then they have this base platform, and they can change the head of that platform and make a new car, make a new model, and then sell this model to a different target group, to different customers, and so on. One example here, Volkswagen has built the Audi A4, a very decent car, and the Lamborghini Urus, a very luxury car, on the exact same platform. There's a pricing difference of more than 200,000 euros between the two cars. Platforms are very powerful. One platform with multiple heads. If automotive industry can build cars like that, well, we are smart software developers, we are smart DevOps people. Should we be able to do the same with our software? Let's look into this. How does that work with software? One of the main goals of platforms is to increase the development speed. But we still have to meet all the requirements that we're getting for our software. In order to have the right balance between this development speed that we want to increase and meeting all the requirements, we need something that helps us here. And this is abstractions. But often those abstractions also come with standardization. And platforms enforce that. Platforms enforce standards. if I talk about standards, people often say, I don't like standards because standards are taking away the freedom. Standards are taking away the flexibility. If there's a standard, you have to stick to that. You have to follow that way. And if you want to do it differently, it's against the standard. So often you're not allowed to do that. People often think, if they hear standards, of limitations. Now my bold statement. I think it's exactly the opposite. Standards enable innovation. Standards help you to scale. And standards remove friction in the process. I want to give you a few examples where I believe that is true. Think of this highly standardized piece of paper. 210 by 297 millimeters. Not roughly 200 by 300. No, exactly 210 by 297 millimeters, which is, by the way, exactly 1/16 of a square meter. So this standard is called DIN A4, and I believe it's a very good standard. No one has to argue how big a piece of paper has to be. We can rely on that, and we can build accordingly. We build like a lot of other things based on that standard, like envelopes, folders, drawers, pockets, and so on. We even build printers that fit DIN A4 or fax machines, but don't use them anymore, please. And yes, if you have that standard, you have to adjust to that standard. If you write a letter, for instance, and you have a very, very long sentence, you have to include a line break because of that format. And you have to start in another line. Or if you draw a picture, you have to accommodate that to the format. But does that standard limit you? Does it limit you to write great texts? Does it limit you to draw nice pictures? Well, we have seen a lot of really good texts and artwork on this piece of paper, so it doesn't limit us. Another example, think of containers, shipping containers, also highly standardized. They are all the same, like rectangular closed boxes, 20 foot or 40 foot size, and they can be stacked and they can be connected with those twist locks. Different features, some are general purpose containers, some are tank containers or refrigerated containers and so on, but they all use exactly the same standard. So you can fit them on a ship, you can fit them on a truck, and it fits on rail. And if you think of containers, it sounds so obvious to do it like this. But believe me or not, there was a time before containers, and it's not that long ago. What did people do? They just take everything and put it in bulk on a ship. That was not really efficient for the transfer. But then with containers, they reinvented how to do that. They reinvented the transport, the unloading, the reloading, and that actually redefined supply chains. And that enabled global trade at scale. So containers are a standard for transportation. They are a platform. Do we have something like this in technology? I don't use the obvious container example because you can imagine that. Let's go a bit more low level. We do have a standard of HTTP. We are using HTTP to ensure that your browser can talk to a web server. And we're using HTTP everywhere. We can't imagine a world without HTTP. Well, there are certain limitations in HTTP. But still, think of what have we achieved with that protocol. Like everything we do with the internet, which is basically our job nowadays. All of that because of that standard that allowed us to connect everything. So standards enable innovation. We have to realize a few things now. That's the first learning from the talk. Locking things down, agreeing on things can boost innovation, can boost creativity. Because standards and abstractions help us to move or remove this cognitive overload that we would have otherwise. They help us with increasing speed of development and still meeting all the requirements, and we're getting more and more requirements. So if you want to be successful, you need abstractions. If you want to be successful, you need standards. We need platforms. But the question is, if we need those platforms, what makes a great platform?
I think it's a complicated question, what makes exactly a great platform, but something that I'm 100% sure is that if a platform is implemented correctly, then it's going to automate and enable DevOps at scale. And that's exactly what we are looking for. And we are still a little bit far away to really understand exactly how a great platform, or how actually a digital platform looks like a great platform. But let us dive on the capabilities and characteristics that absolutely every successful platform has. You may have thought before joining this session that if there are a lot of abstractions in place and a lot of standards in place, then a platform is going to limit you. And actually, it's exactly quite the opposite. A platform should enable you. A platform should abstract complexity, should make it easier for you to use. Absolutely every single team that you have in your company, you would like that that team actually use it as that platform. And in order to do that, you would like to use a lot of shared components and a lot of transparency also as well. If a lot of teams actually are going to use that platform, a concept that we need actually to introduce here is the shared responsibility. So absolutely every single team should feel responsible to just treat that platform as their own project, as their own software, as their own technology, and everything to just make it the best directly to keep using. If a lot of teams are using that platform, it becomes obvious that the marginal cost is going to be really low. So that means if every single team actually builds and deploys everything by their own, the total cost of ownership at least is going to be really high. And we are looking for exactly the opposite. By building the platform, we are going to just reduce the marginal cost. So how does actually a shared responsibility look like in the sense of who feels responsible for that? And how do we actually really implement transparency on that? Well, in order to really get a true understanding of how the platform is built, how the platform, or for what is the platform intended and for what is the platform not intended, we need to just have good documentation. So have the possibility to share documentation between the team in order so that they really understand how it works under the hood. We do not want to have like a black box in sense of that the people do not know exactly what happens inside. We are looking for kinda exactly the opposite. And again, the idea here is not to force absolutely anyone to just use the platform, but instead building in such a way that absolutely everyone wants to use it. This is the first characteristic. Let us dive to the second one. And the second one is actually about making a platform extensible. Extensible, but also scale it across the organization as well. So we do not want to be the bottleneck of any developer team, neither for any operational team as well. But that doesn't mean that you have to foresee which one is the feature that every single team needs in the future. Kind of the opposite, like stay flexible, really ask for feedback and really try to get to know every single team, what they are using, what they need, and how to help those teams to just find a standardized way to implement it across the whole company. How do we do that? Well, the idea here is to make the platform and build it in such a way that it's self-service, so that absolutely every single team is going to have the possibility to just deploy the needed capabilities by their own. And one of the ways of doing that is by having a good UI, a good user interface with a good user experience as well. So how does actually scaling look like? Well, absolutely every single company would like to just grow in the sense of more developer teams, more operational teams, and also to just somehow like grow the business side as well. And we want to just accompany that process and give the possibility all the developers and all the operational teams to not become the bottleneck, but at the same time build as fast as possible all the different projects that they need through the platform that we are also giving them to them. And again, here the idea is to stay always flexible. So don't enforce any team to just use a specific pattern or use a specific way of working, but the other way around, just to try to understand how they work and try to find a standardized way that works for all the different teams. The third capability that I brought you is about making it evolutionary. So that means, of course, absolutely everyone is going to agree here in the room that we live in a digital world. And digital means that we are always trying to somehow be have the better technology or be actually keep the pace of new software and new capabilities that come into the game. And exactly the same for the business side. And we are looking exactly for this capability in a platform as well. So that means that we want to actually also understand if there is like another layer of automation or another layer of abstraction that actually our teams always need, or that they need in order to move forward. But always, 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 we want to keep a focus in making it cheaper and making it more efficient, but at the same time, keep the simplicity so that every single team wants to use it as well. What's the key here? How do we actually achieve to have an evolutionary platform? And the answer is by treating it like a product. So have that mindset of develop the whole platform as it would be a product. Have a roadmap. Try to brainstorm all together which one are the features that they need. And try to, again, implement it so that every single team wants to use it. Something that I'm still learning with the time and that experience is actually giving me, that it doesn't matter if you are really good knowing all the characteristics of something. If you really know end to end how a business process looks like. If you are the best on doing it, and if you have the best intentions, if you do not have a mechanism in place, there isn't any way that you can actually scale that across the whole organization. So what I brought you here are 4 different mechanisms that hopefully it allows you to just map the idea and a specific characteristic that we need with the goal that we are actually aiming to achieve with that. The first one is related to abstractions. So that means we want to build an application that hides the complexity, but at the same time keeps a really high transparency to the whole different teams. We also want to have some sane defaults. So that means that we do want to avoid the mistakes but that any single team can do by doing things manually, but at the same time try to keep the flexibility. Third thing is related to automation. So we want to keep and help the teams to just gain a better and a faster speed, but still without having a friction in the process. And last but not least, the 4th mechanism that I brought you is related to the controls. So we want to really enforce compliance with some guardrails, some security measures on top, but still without losing the focus on the shared responsibility concept that I just introduced to you before. And I strongly believe that if we do have these characteristics in place, then the platform that you're going to build is going to be a successful platform. But I think, Martin, the question would be, whom are we going to enable with that platform?
Yeah, that's a good question. And let me start there with a quote from Peter Gillard-Moss from ThoughtWorks. He said that platforms are a great way to centralize expertise. But he also says you cannot centralize innovation. You have to leave this innovation to the teams that are closest to the customer, because they have the best ideas and they know how to build innovation on top of a platform for their customers. Let's look into those teams. I don't know if you've read Team Topology's good book. It's really looking into that. How do those high-performing teams work? They are usually small and self-sufficient. That means they can do most or maybe all of their work independently from other teams. And they can make all or maybe most of their decisions on their own. How does that work with a platform? Here we need to talk about 2 different approaches. Maybe one that you associate with platforms in the beginning, centralization, but we also want to talk about decentralized approach. Let's see how that works if you have a centralized platform. Well, we have a platform that is designed and operated by our platform team. And we learned our platform has to be evolutionary, so we have to add new features to our platform all the time. So you're going to add those features. In a perfect world, let's imagine the perfect world. We have our platform team. It's super smart. They anticipate every single feature request before someone asks, and then they implement that feature before someone asks, and they just have it. When someone comes and like, we need this feature, it's like, let you ask, yeah, here it is. Now let's go back to reality. In reality, those app teams approach the platform team and say, like, we need this feature and we need it tomorrow because we have like this urgent customer project and the platform doesn't help us, so you have to extend the platform and add new features. What then happens, the platform team needs to understand that feature, the feature request, and then see like, how can we build that into our platform? And then they have to build it. And all of this while operating a huge platform. So you're basically moving the cognitive load that was like the idea captured by the app team to your platform team, from the app team to the platform team. And if you get more and more app teams, and that's the idea of a platform, you have like maybe 20, 30, 40 app teams doing this, you will kind of overload the platform team. And the platform team will eventually become your bottleneck. Because, and that's the quote from Peter Gillard-Moss, you not only centralize the expertise here, you centralize the platform innovation. How does this work for a decentralized platform approach? So your platform team provides supported blueprints. That's a new concept here. Supported blueprints from the platform team, and the app teams can use those blueprints and maybe create their own version of it. So we are putting more responsibility in the hands of the developers, of the app teams, so they can own the entire life cycle of their app. It's true full stack. That's what like everyone wants. Have full control, full stack, including the platform components. They can use the platform components. Now you might say like, yeah, but then they have the cognitive overload. But they don't get this cognitive overload because they get platform components, blueprints. They get abstractions from a platform team. And the app teams, they can operate. They have the full responsibility. They can operate their full stack. They can meet like all the central requirements because that's kind of baked into the blueprints. And they can evolve the stack together, the app teams and the platform teams, because you can easily fork platform components, adapt them, change them. So in this case, hearing back what Peter said, we are centralizing the expertise into blueprint, but we somehow decentralize the innovation to our app teams. And that's exactly what we want to achieve when we're doing this. So this decentralized approach, I think that's pretty new because people often don't think about decentralization when talking about platforms. That helps us to scale the platform by thinking of our bottlenecks and then removing the bottlenecks and shifting the responsibility from the platform team to the app teams. But it is still a platform, just a decentralized platform. Like we talked about, like now we have a bit more responsibility between the app teams and the platform team. How does this work? And that's an interesting question. And here we have to look into some patterns, how you can build this and how you distribute the ownership.
Well, there are different ways to just make everyone feel responsible for every single part of the platform. Nevertheless, there shouldn't be any finger pointing. Despite which one of the 3 different options that I brought you here related to ownership patterns you pick, you always, and actually you never should lose the focus on 3 different characteristics. The first one is that you do have to ask yourself which one is the objective of building it in such a way. Which one is the added value that you're going to add to all the different teams that they are going to use the platform? And last but not least, you never have to lose the focus that the platform is there to just help the teams accelerate the development and to also reduce the cognitive load. So the 3 different patterns that I brought you is something that I'm slowly seeing, or actually I see a lot with different AWS customers from our side, that they are just picking for the different AWS environments. So what I brought you is to just something that makes it more like tangible. So how can we actually implement it and how does it even look like for this ownership pattern? And the first one is about AWS accounts and how they treat those AWS accounts as a platform. The easiest way to just understand this, in my opinion, is by visualizing this as an account vending machine. So the platform team is going to provision AWS accounts to every single team that actually needs them. And they are going to have basic components set it up in a specific way with standards from the organization that are going to help you to boost the development. Which one are those standards? It could be like networking. So all the networking stuff related to the networking topology. Do they need like private subnet? Do they need like public subnets? Do you need any specific VPN? How to set up the VPC, for example? Also the security measures, so some guardrails, some policies, some things that are going to enforce some specific ways of implementing stuff directly in your organization. And also something related to observability, so something related to how to monitor your different workloads, how to set up logs, how to use traceability. And all those basic components are going to be there and present in this type of platform for those teams that need like a really broad flexibility. The second ownership pattern that I brought you is something with a more in a combination of a centralized and decentralized approach, which is a little bit less flexible and with a little bit more of abstraction. And this is the case of having a managed cluster. So that means there might be some teams, some developers, for example, that they say like, sorry, but I have no clue how networking works. And I also do not need it in order to implement a specific project in a container. And therefore, I would like to have a higher level of abstraction, have a possibility of use a managed cluster, but I would be really interested to have some CI/CD capabilities in place that allow me, for example, to have different deployment options for my containers, like a blue-green deployment or a rolling deployment, but also have some other more specific capabilities related to observability, like for example having health checks already in place to know if a container is already up and running or not. And of course, something that they also would like to know is about like controls, like to how to access those specific clusters with a specific user, or also control the network traffic. So again, this is yet another possibility, but it's not the only one out there. I also brought you a third one that I'm seeing quite a lot, and this is gaining a lot of traction lately. It seems to be like the modern way of implementing an ownership pattern for most of our customers, which is related to have some deployable application patterns. So that means having some blueprints, some specific ways of already implementing stuff that allows them to just pick a specific application from a service catalog, for example, with some configurations already in place, and take advantage of it and keep implementing on top of that. How do you actually can achieve such a blueprint from the platform engineering team? Well, you can use, for example, a lot of infrastructure as code with CDK, leveraging L3 constructs. And again, here, what we're going to do is that the ownership of the account is actually going to be from the application team or from the platform team. So it's really from both sides as well. And this is a really interesting pattern that we are seeing for high-performing teams, for those teams that are completely independent, and they that also need a little bit of flexibility as well. But let's see how does it actually look like in reality with an example. So how can we actually implement and put this everything work together? Again, what I said at the very beginning, we do not want to force no one to use a specific pattern, but the other way around. We just want to make it really attractive by giving a lot of possibilities and make them free of choice. So we have the platform engineering team that is helping and supporting a lot of different teams. In this case, 4 different teams. They are all working in a decentralized approach. All of them need AWS accounts to just deploy the workloads and work directly on the projects that they are developing. So every single team is going to get an AWS account. The first team needs a lot of flexibility. So they just take the account as it is, and they just go for that a specific ownership pattern. The second team instead, they are running Kubernetes. So they would like to have a managed cluster. And actually, they would be interested that on top of that, they have another blueprint, so this specific other pattern that we talked about, for example, Helm charts. The third team is also in the containers game, but they are using containers. So they're using Docker. So that means that they would just have a managed cluster as an ownership pattern. And the last team, the fourth account, is completely into the serverless game. So that means they would just like to have a pattern, a blueprint that allows them, for example, to use API Gateway, Lambda, S3, SQS, SNS, and any other service that is related to that serverless pattern. So what's the beauty here? That you do not have to just pick one ownership pattern, but the combination of all of them is what exactly makes a platform a great platform. Martin, you do have experience building a lot of platforms. So do you have maybe some guidelines that you can also share with us?
Sure, let's look into that. And again, like we see, like we can do things centralized and decentralized. We are really familiar, I think, with the centralized approach for platforms, but they might have some limitations. So it's good to think of like the combination of things that you can do. Decentralized platforms are becoming more popular, and they're a great way to have the platform team and the app teams. So I would say if you do decentralized components or decentralized platforms right, the way that you guide the teams, that you offer them to be faster and more efficient, can be seen as a golden path. And this concept of a golden path is really popular with in the IT industry. I also heard about the concept of a paved road, and I want to introduce another concept. That's the golden path on a paved road. But outside of that golden path on a paved road, we do have some guardrails. That's important. And what we want to achieve with our platform and our platform components is that we want to give the developers an opinionated way how to use technology, but also in a supported way how to use technology. So the goal of a platform, of this golden path, is be giving them an opinionated and supported way of using technology. So we should try to make it as easy as possible for the developers to use our platform and to follow that golden path. But the golden path is not the only direction. We have this paved road, and we even have like something outside of the paved road within the guardrails. So we should be flexible. If someone has an alternative idea how to solve that, don't force them on platform, say like that's the way how you have to do this. Give them the freedom to go a bit left, to go a bit right on that paved road to a certain degree. Maybe this will open another road. And this might open another shortcut, which later becomes your new golden path. That's the idea of evolutionary platform. Let the teams, give them the freedom to see what they can do, and then see if that is helping you and driving your platform. Having a golden path, which is not forcing you to do something, but encouraging you to go that way, you remove the finger pointing. Because no one can say like that's the only way that is allowed. That is the preferred way of doing things, but you don't have the finger pointing that someone says like I can't do it differently, and that is helping the teams to develop quickly. So that's the idea of this golden path. The golden path should enable many teams, maybe not all teams, but many teams. So, and if you want to have a golden path that helps many teams, well, you can invite all of them to support this golden path. So everyone should be able to contribute to that golden path, make it better, or like find a new direction. So, and that's exactly the idea. Marina talked about this already, having this product mindset. If you build a product, you're always looking for ways you can improve this, and you're happy for every input. Like you don't think like this is the only person that can give feedback on a product. Like get feedback from everyone and think of platform as a product. It's the common product of your organization that should enable as many people as possible. So how to build those platform products, treat them as platform components and treat them as a product. I learned a lot of things during my career from open source. And we as DevOps people, like we use open source libraries a lot. So we can learn a lot of things because our platform components should be treated like successful open source projects. Because you want everyone to contribute and to evolve this one. So VDACs, that's the rule. If you want to learn how to build successful platform components, they should be versioned. That is super important. Version platform components. So you have a version piece of software where everyone can contribute, but they also allow you to like maybe use an older version because you can decide and you can contribute at a new version and so on. And if it's semantic, the versioning, like everyone understands on what they are reliant. because they're kind of reliant on that platform, on those components, so they fully understand what version of the platform they're getting. Make it decentralized. We talked about this a lot. It enables like an independent lifecycle of platform components. Also super great approach, and it makes the scaling so much easier if you have like those small pieces that you can scale. It's so much easier instead of having like a big platform where you have to consider so many different things. And if you have small components, it reduces the blast radius. And then make it usable. We also talked about the ease of use. A product mindset will help you. Good accessibility, good documentation, scaffolding, maybe think of an SDK on top of that, think of a CLI, a good UI, integration patterns, and so on. Make it customizable, open to changes. We also talked about this. Allow people to parameterize things that you're offering, allow to choose escape hatches, allow them to fork your product and build a better version out of it. And transparency, like don't build a black box. We learned people are relying on a platform. That's actually their job. They are responsible for what happens. So if you make it a black box, it's hard to rely on that. You don't have that trust. Build a white box. Don't hide the implementation. Be proud of the implementation. Show it to everyone. They will like it and they will tell that you like it. And self-service. Everything is automated. You should be able, if you want to get something from a platform, you should be able to request it and deploy it via an API. That is how you build evolutionary platforms. One last thing to mention about platforms. Stay ahead with your platform. So your platform always, if you want or not, like it always builds on a certain base. For instance, you build your Kubernetes platform on top of a cloud provider or a data center or whatever. And your platform should evolve. Your platform should get better all the time. And also the base evolves all the time. Often it evolves very, very fast. So if you don't evolve your platform, if you don't adapt it to the base, and you stick to whatever you have built all the time, you have a sinking platform. You build a platform that is forcing people to do something, but not adding any benefits. And such a platform is a burden for every developer. If you evolve your platform on a regular basis, if you adapt it to the base, if the base has more features, make them available and build on top of that, you will have a floating platform. A platform that is always ahead of that base and that is adding real benefits to the developers. And that is a platform that is enabling teams. So always build floating platforms. What did we learn today? A few key takeaways. We learned standards are not limitations. Standards are often the key to innovation. And don't build a platform for the sake of having a platform, because everyone is doing it. Build a platform that is enabling your teams. Think of what would enable your teams. And then build a platform that is extendable and evolutionary. And then also think about decentralization of your platform. Don't think about like platforms have to be centralized. Decentralization, decentralized blueprints. And then build this golden path for your developers. And always stay ahead with your platform. Thanks a lot for listening this afternoon, and we really value your feedback. There are a lot of QR codes. These 2 QR codes, you can ask us questions on LinkedIn. This QR code on the top, you can give us feedback for the talk. 15 seconds, we highly appreciate your feedback. Thanks a lot for listening.
Now we can start queuing questions session. So we have our first highlighted question that you can see.
In the past, let's say 20 years ago, platforms were also managed by their IT guy. Do you think it might happen again with the introduction of AI getting merged? A good question. Of course, yeah, you can think of like what would be the benefits, like how can you help developers getting faster, and especially Gen AI can help to increase the development speed. Also, that can be considered as a type of platform to increase the developer speed and the quality of that. So it's a combination. If you look at the runtime, maybe Gen AI. If you look at the developer experience, and like platforms are always there to help developers building better products. Jenny, I will definitely be a part of that.
Remember the evolutionary capability. So we always want to keep the pace of technology. And that's one of the ways also of to just bring that technology directly to the platform. So let's see.
Thank you.
So the next one says, can you give a good example of what is a pattern? Would it be something like a Chef cookbook, Ansible playbook, or Terraform?
Yes, yes, and yes. It could be various patterns. Like we mentioned a few of them. A good pattern can be built in something like CDK, for instance. You can also do this in Terraform or Ansible. Like, we don't look too much at the tooling. It's more like question, does the tooling help you to achieve that? And there are great ways. Can tell you a bit about the CDK, for instance. We encourage you to look into that. If you look at infrastructure as code, you can do it on the very low level, but the ideas of a platform of blueprints to build it on a higher level. For instance, we have a blueprint where you only need 4 lines of code to spin up an entire account with VPC, all the security stuff, and Fargate cluster, and you only have to provide the parameter where the container is. And then everything runs fully resilient and so on. That's the idea of an abstraction. And you have to think, like, whatever tool you pick, does it allow you to build those abstractions easily? And also for the developers then to use those modules to spin up their own infrastructure.
Great.
So the next question reads, platforms are great, but suspiciously close to matrix organizations with subsystem teams. How can we avoid their problems? Splittering responsibility, waiting, or something else?
I'm not 100% sure what's the direction of the question. Like the responsibility, like we talked a bit about like this, where do you put the responsibility and also this cognitive load, and you want to remove the finger pointing, and it's different. Like different types of platforms are successful or not successful in different organizations. Look at your organization, like look into Conway's law, how that works. That's actually also a thing for platforms, and understand, like, you know, what would enable the teams, like what are like the dependencies between the teams, and then design a platform that is removing the finger pointing that might happen in your organization. That is like one of the ideas. And decentralized platforms definitely are more flexible to accommodate for that compared to centralized approach.
I don't know if that one was the direction of the question, but if it wasn't, just feel free to just jump in.
Seems like this question was answered.
Yeah. So the next one reads, does decentralized path lead applications team to start caring about the infrastructure also, as they will start creating infrastructure according to different blueprints?
It makes it transparent for them, so they know what is happening, so they can have the full responsibility, but you don't want to, like, you don't want to have an app team building a front end that should understand like the network too much. You want to give them the abstraction that they don't have to learn network from scratch, but they have the full control in case they want to modify this. If they're familiar and they say like, yeah, but we need something else, it should be extendable enough that they can change it, parameterize it, but they don't have to. That's the right level of abstraction layer. In an ideal world, if there's a team that is good building Java containers, build them an abstraction where they can easily deploy Java containers, and they don't have to see all of that. That's a perfect abstraction, but so transparent that they know what is going on under the hood.
I really, really like that there are so many good questions. I think we have the last one. Transferring ownership to application teams would require a strong trust in those teams and the expertise of those teams. And actually building such an sorry, I think I didn't understand it. Transferring ownership to application teams would require a strong trust in the expertise of those teams, and actually building such an expertise wouldn't transfer the ownership, maybe?
Trust is always like, if you're relying on something, and if you have like a platform team building something for you and you have to use that and it's in your stack, yeah, you have to rely on that. Yeah. And you have to trust that team. How do you get trust? The question is like, do you trust them because you know them, you're friends with the other teams, and you say like, yeah, they're good guys? Or do you get the trust because you have transparency? and you have KPIs, if it's measurable, like seeing like the availability of those components, like how resilient they are, if you make it measurable, if you have data for that, then you can make a data-driven decision to trust those components.
So the questions have ended, and you may still ask our speakers some questions in the Ask Me corner. So thank you a lot.
We also have some stickers actually, so if you would like to paste it on the computer or whatever else also as well, we will be more than happy to stay there in the Ask Me Anything corner with stickers as well. I'm more than happy to just answer any other question that you have.